Hello, my name is John Hill, and I'm one of the Siemens product specialists for EandM, your West Coast Siemens distributor. Today, I want to talk to you a little bit about how you're protecting your 24-volt DC circuits in your control systems. What I have on the screen here is a digital representation of a Siemens SITOP power supply demo. What we have on here is we have a PSU 6200, which is a 10 amp output on it. We have a selectivity module, the 1200 with the 8 outputs. We have a S7 1500 PLC and a digital input card. We also have kind of grayed out here right now until I start moving things around, some Siemens 5SY breakers that are going to our loads. So we have a selectivity switch here. We can show these loads being protected by our circuit breakers, or we can show them being protected by our selectivity modules. We also show here that we are using, because we're switching back and forth on this, we are taking our power direct from the PSU to the PLC and to our HMI here. We have an example of a comfort panel here. And then we have several screens on this comfort panel. And these screens on here are part of an application example. So everything that you see displayed in this demo unit is something that you can get off of the Siemens support site. So any programming that we're simulating in this PLC and all the screens that are shown here are something that you can easily get a hold of and replicate this system on your own, as far as implementing this in your own plant. So we're going to start by switching this to our MCB, our microcircuit breakers. And when we do that, we have one of our indicator lights here has some capacitance on it, and that's going to end up tripping our breaker. And we have to actually engage that breaker again before that capacitor bleeds that voltage and that capacitance off of there. So you'll see that as I switch here to my circuit breaker. Uh, See, this load here has tripped. And if I try and engage it now, because that capacitor has already bled off, it's going to trip again, and then I'll need to engage it one more time before that capacitance fully bleeds off. And then we engage it again, and then we get our circuit to hold in. So in this, we have protection on these circuits. You saw that when we tripped this one. But it's not really what we want, right? We have this capacitance, so this is going to be a problem every time we engage this circuit, and we're going to have to reset this a couple of times to try and catch that before our capacitance bleeds off. If I come over here, I can slow this down a little bit, which is going to increase the current. We're putting a drag on that little motor, but it's not enough to trip our breaker. And so if we had a couple circuits like this, it might not trip our individual breakers, but the sum of them might end up tripping our actual power supply. We also have a short circuit that I can add here, and that's going to actually trip our power supply itself, and you're going to see a blip on that when I put that in. We lose everything for a little bit. This resets, that part comes back in. We still have our short here, so this is off right now, and then I can reset that circuit. So we get, that dead short can cause problems because it might actually trip our power supply before that breaker trips. And, we saw the capacitance, we saw the potential overcurrent on a load and what that might indicate. So if we go back and we switch over to our selectivity module here, and like I said, this is the 1200 selectivity module. It's a 10 amp unit with 8 outputs. And we can kind of dial in each output to have a specific level of output. We can kind of see those on our screen that we have here currently. And so really we're just working with these first 3 outputs. Those are all 3 set to 2 amps as a current limit. We do see the higher ones are set up to, even up to 10 amps on that output 8. Obviously, the sum of these currents needs to be within what our power supply is when we're doing that. So, we have to set these up accordingly and monitor them accordingly. But now that we're looking at this, and just kind of flip through the screens a little bit here so you can kind of see what's available in this application example if you pull these in. This one here is kind of interesting. It's showing our output for the power supply itself. If we come over here to the selectivity module and we go to the actual outputs there, once these lights are on, they have a very low drain. You have to get up to a certain threshold for these numbers to switch, and they're not going to here for us today. But if we look at this output one and I go back and I put that load on this little DC motor, we'll see that go from 2 to 3. And it's not quite at full 3 because it takes 5 seconds to trip. And so each one of these outputs on this has a specific tripping time based on if it's at or just slightly exceeding 1.5 times the rated output that we've set it up for. It'll trip in a second. If it's below 1.5, between 1.5 times and 1 times the output, that'll take about 5 seconds to trip, which is what we see on this circuit here. We can reset it here with our little button and engage that motor again. The other thing, when we switch to this selectivity module, this unit here did not trip like it did on the circuit breakers. So this unit is able to sense that that's a capacitive load and gives it a little bit of time to charge that capacitor up and keep that circuit going. The other thing is, if I switch this unit off again and we switch it back on, we'll notice here there's these outputs come on in kind of a stepped format. So it doesn't hit that selectivity module and that power supply with the full load all at once. It does, engage those one at a time in rapid succession, about half a second between them, give or take. And that is settable. You can, vary that a little more if you want to, or shorten the time up some more to give a more quicker response depending on your needs and what your system has going on in it. But the nice thing, that output 2 stayed on right away for us. I can also enable this short again to kind of show you when we enable that, it immediately trips that output 3. When I remove that and click reset, we're back on, put it back in. If I try and click reset, while that's in there, it trips right back immediately. And then if we watch up here, it's telling us what's happening here. If I go back to this output 1 and I slow that thing down again, we wait that 5 seconds for it to trip. It tells me, my current out is above my current set. It doesn't tell me that it's 1.5 times or more, so that tells me that we were just below that 3 amp threshold when we're actually tripping, even though our current said 3 amps on this unit. There is some rounding going on in there, I believe. And then we can reset and have everything running again. When we look at the green lines over here, this is indicating that both of these units do have diagnostics available. It's just a digital output, and so that's why we're showing a digital input card here. And basically, it's just sending a pulse signal across that input line, and then the programming in that application example is able to decipher what these pulse signals are telling us, and that's what's filling in, our status and all the information that we're seeing in our HMI here. So you can see that, pairing the Siemens SITOP power supplies with the selectivity modules, and there are several different selectivity modules to choose from, some with more features, some with less features, 4 outputs versus 8 outputs. We even have some that are kind of gangable when you get up into that PSU 8600 format where they're built right into the power supply, up to 40 amp units that you can use. So there's a lot of variations that you can get here to protect your control circuits. And you get a lot more information, right? We get this, and we can protect things, more individually, so that we're not having one thing take our entire circuit down or our entire system down, like we saw with that short and the breakers, where we even lost our PLC and our HMI. So I encourage you to take a look at the SITOP offerings from Siemens and the entire lineup that they have. We have a lot of different power supplies with different features. This one has the diagnostics. Some of them are missing the diagnostics, but then you get a level of diagnostics if you pair it with a selectivity module and have a little more protection. So a lot of different offerings. Take a look at their offerings, and if you have more questions, please reach out to us and we'll help you design a power supply system for your DC power needs. Thank you.